Hello students, today we will start matrices, chapter 3 of class 12 NCERT mathematics. The word matrices is the plural form of matrix. The evolution of concept of matrices is the result of an attempt to obtain compact and simple methods of solving system of linear equations. In this session, we will learn the order of matrices, types of matrices, and formation or construction of matrices. Let us consider the system of simultaneous linear equations. Here we have taken two cases. Case 1, 2x minus 3y equals to 7 and 5x plus 4y equals to 11. It is a system of linear equations with two variables x and y. Another case, in case 2, 3x minus 5y plus 7z equals to 12. 2x plus 7y minus 3z equals to 13 and 7x minus 9y plus 5z equals to 15. It is also a system of linear equations with three unknowns variables, that is x, y and z. Now if we represent these two cases in matrix form, the LHS of the first case we can write like this: 2 minus 3 5 4, and RHS we can write like this: 7 11. Similarly for case 2, LHS we can write like this: 3 minus 5 7, 2 7 minus 3, 7 minus 9 5, and RHS of case 2 we can write like this: 12 13 15. Each array of the above type is known as matrix. That means the arrangement of such type in row and column we can say as a matrix. So from the above discussions we can conclude that the definition of matrix as this: matrix, a rectangular arrangement of mn elements in the form of an ordered set of m rows. Each row consisting of an ordered set of n elements is called an m by n matrix. Here m cross n is read as m by n. Such arrangement is enclosed by either this third bracket or first bracket. The numbers or functions in the array is called an element or entry. So inside a matrix, these numbers are called element or entry of the matrix. Let us take one matrix. Matrix always denoted by capital letter. So capital A equals to, in between third bracket we have taken, these are the elements of the matrix. First element, here small a suffix is 1 1. So the first one stands for the position of row and second one stands for the position of column. That means first row first column element is a11, first row second column element is a12, first row third column element is a13. Similarly first row nth column element is a1n. Second row first column element is a21, second row second column element is a22, second row third column element is a23, like this. Second row nth column element is a2n. So if we follow like this, if we take m number of rows, then the element of first element of mth row is a m1, second element of mth row, that is a m2. Like this, the last element of mth row is a mn. So in this matrix, the total number of rows are m and total number of columns are n. This horizontal arrangement is known as row and the vertical arrangement is known as column. Now we can write this A matrix as this compact form: A equals to, in between third bracket, small a ij, whose order is m by n, where I is greater equals to 1 less equals to m and j is also greater equals to 1 less equals to n, and ij always belongs to set of natural number. Okay, now when two matrices are said to be equal, so for this we have a condition of equal matrices. Two matrices A and B are said to be equal if and only if they are of same order and their corresponding elements are equal. That means in this A matrix, the first element, that is small a, should be equals to the first element of this B matrix, that is E. So A should be equals to E. Similarly, B should be equals to F, C should be equals to G, and D should be equals to H. If these are equal, then we can conclude that capital A, this matrix, is equals to capital B matrix. So when two matrices are equal, if the corresponding elements are equal, then the two matrices are said to be equal matrices. The vice versa is also true. That means if two matrices are equal, then the corresponding elements are also equal. Now types of matrix. The first type is row matrix. What is a row matrix? A matrix having only one row is called a row matrix. So here we have taken a matrix capital A equals to 1, 4, minus 3, 5. Clearly only one row is there because we know that the horizontal one is known as row. So here, since it has one row, this matrix is known as row matrix, and the order of matrix is 1 by 4. See here, 1, 2, 3, 4. 4 columns are there. That means number of row equals to 1 and number of column equals to 4. So order of the matrix is 1 by 4. Now the second one is column matrix. A matrix having only one column is called a column matrix. Thus A equals to 370 is a 3 by 1 ordered column matrix. See here, the number of rows are 1, 2, 3, but number of column only 1. So it is a 3 by 1 ordered column matrix. Here the first number represents the number of row and the second number represents the number of column. Third one is zero matrix. A matrix whose each element is 0 is called a zero matrix or null matrix and denoted by the letter O. Here in this matrix all the elements or entry are 0. So it is a zero matrix of order 2 by 2, since here number of rows are 2 and number of columns also 2. So this is a zero matrix of order 2 by 2. In this second one, number of rows 2 but number of columns 3. So it is, since all the elements here also 0, so it is also a zero matrix of order 2 by 3. Now square matrix. A matrix in which number of rows equals number of columns is called a square matrix. That is 2, 3, 4, 5 is a square matrix of order 2 by 2. That means what is a square matrix? When the number of row is equals to number of column. Here number of rows 2, number of columns also 2. That is a square matrix of order 2 by 2. Similarly in this case, number of rows 3 rows are there, 3 columns are there. So the order will be 3 by 3. So it is also a square matrix of order 3 by 3. Next, diagonal matrix. What is a diagonal matrix? A square matrix is called a diagonal matrix. So for diagonal matrix, the matrix should be a square matrix first. This is the first case. The matrix should be a square matrix. A square matrix is called a diagonal matrix if and only if all its non-diagonal elements are 0. The diagonal elements may or may not be 0. For example, see the first matrix 3, 0, 0, minus 1. Here the diagonal elements are non-zero, and except the diagonal elements, all the elements are 0. That means the non-diagonal elements are 0. For diagonal elements, we will treat always from the left side corner. So this is the diagonal. This is the diagonal. Okay. In this case, see the diagonal elements 5, minus 2, 0. So diagonal elements are 5, minus 2, 0, and the non-diagonal elements are all 0. So it is also satisfying the definition. So these are the diagonal matrices of order 2 by 2 and 3 by 3. So remember, for the diagonal matrix, the non-diagonal elements always should be 0, and the diagonal we will take always from the left side corner. Only one diagonal will be there. Next one is a scalar matrix. So what is a scalar matrix? A diagonal matrix in which all the diagonal elements are equal is known as a scalar matrix. Here we have taken a matrix. See, the diagonal elements, both the elements are -2 and the non-diagonal elements are 0. So it is a scalar matrix. In this example, all the diagonal elements are 3 and the non-diagonal elements are 0. So it is a, first of all, it is a diagonal matrix, and since all the diagonal elements are equal, so that is why it is a scalar matrix. Next one, identity matrix. A scalar matrix in which each diagonal element is unity is called an identity matrix or unit matrix. That means if the diagonal elements are 1 or unity, then the scalar matrix is known as identity matrix. This is a 2 by 2 order matrix. Here the diagonal elements are 1. This is a 3 by 3 order matrix. Here the diagonal elements are 1. So in both the cases, all the diagonal elements are unity. That is why this matrix is known as unit matrix. The order of the first matrix is 2 by 2. The order of the second matrix is 3 by 3. In general, we denote the unit matrix by capital I suffix n, where n denotes the order of the matrix. Now, since the unit matrix is always a square matrix, that is why we will always denote by only one number. Now we will learn how to construct a matrix, that is the construction or formation of matrices. Here the question is given, construct a 2 by 3 order matrix whose elements are given by small aij equals to 2i minus j. So first you have to take a matrix whose number of rows are 2 and number of columns are 3. So in step 1, we have taken a matrix A whose number of rows are 2 and number of columns are 3. So before we have discussed that the first entry or the first element, here the position of row is 1 and the position of column is also 1. So the first element will be A11. Second element should be A12 since it is in first row and second column, so A12. First row, third column, that is why A13. Similarly, second row, first column A21, second row, second column A22, second row, third column A23. So this is our first step. In first step, we have to take one matrix whose number of rows are 2 and number of columns are 3. Now we have to find the elements of the matrix. So what is the first element? A11. That means in the place of I, here it is 1, in the place of j, it is also 1. So in the given condition, here Aij is equals to 2i minus j. That means in the place of I, you have to put 1, in the place of j, you have to put 1. So A11 equals to 2 into 1 minus 1, that is equals to 1. Similarly, A12, that means in the place of I, 1, in the place of j, 2. So we are getting 0. A13, we are getting minus 1. In same method, A21, that means in the place of I, we have to put 2, in the place of j, we have to put 1. So we are getting 3. A22, 2 and A23, 1. Now put the values in step 1 matrix, that is A equals to 1, 0, minus 1, 3, 2, 1. So like this we will construct a matrix with given conditions. Okay. Now let us solve one examples. Here in this question it is given two matrices are given and we have to find the value of these unknowns. Now since in the question both the matrices are equal matrix, that means since here equal sign is given, that means these are equal matrix. So by the definition of equality of matrix we get that the corresponding elements should be equal. So 3x plus 4y equals to 2, x minus 2y equals to 4, a plus b equals to 5 and 2a minus b equals to minus 5. Now in equation 1 and 2, see both the variables are same, x and y. So by the method of elimination, if we multiply equation 2 by 2 and add it to 1 and then solve, we will get x equals to 2. Now put the value of x equals to 2 in number 1, we are getting y equals to minus 1. So x equals to 2, y equals to minus 1. In same manner, if we solve equation number 3 and 4, if we solve equation number 3, that is a plus b equals to 5, and equation number 4, 2a minus b equals to minus 5 by the method of elimination. Here plus b minus b cancel, so a plus 2a, that is 3a equals to, plus 5 minus 5 cancel, 0, 3 equals to 0 implies a equals to 0. Now from 3 we are getting, if we put the value of a equals to 0 here, we are getting b equals to 5. So the value of a equals to 0, b equals to 5. Hence the value of x equals to 2, y equals to minus 1, a equals to 0 and b equals to 5. So like this we will solve the equal matrix questions.